Hello, my name is Mateo Jonkovic, and this is Lab 1 Constant Velocity for Physics 2211. So, the overview of the lab, um, uh, first I'll have an introduction with the models used and equations, and then I'll show the experiment, which is the procedure, the results, and um, the similarities and differences of the two computational model and then the experimental model, and then I'll go over hypotheticals, what ifs, human errors, and then conclude if the lab was successful. So, the purpose of this lab was to compare an experimental object of constant velocity and no change in direction to both a computational and theoretical model of modeling the same situation. So, we use Newton's first and second law and then constant velocity principles. And Newton's first law, as a reminder, is an object in motion stays in motion. And second law is an object with larger mass requires a larger force to move it. So the equations we used were the velocity and position update equations as well as the average velocity equation. So the details of the experiment, the object we use is a tape roll, and the surroundings were external factors like friction and air resistance. And for our model positioning, we use the tracker um, app, and then for the computational modeling, we use the GlowScript app. So for our procedure, we recorded the tape roll at constant speed across the screen, put it into the tracker, used GlowScript to build a computational model, and then compared it in Excel. So the results from tracker were um, pretty much a linear um, change in direction, and this makes sense because it was at constant velocity. And the initial conditions from the tracker, as you could see, screenshotted and then um, written are 0.004950 for the initial position, and then use the velocity equation to determine initial velocity, which is 0.67. For our initial conditions in GlowScript, we made the t less than 1.89 seconds, which was how long the video was. We put our equations into the starter code and used our initial conditions from the actual experimental model, and then made our delta t the size of each frame, and then kept the mass consistent as well. So our results were that the experiment and model were pretty much the same, on the same path, except for a little deviation at the end. So some sources of error that could have occurred was human error in rolling the ball, like at an angle or too fast, and it slowing down, which would affect the tape roll's movement overall. And then friction and air resistance from the ground or air affecting movement as well, because it could have been a source of error which created the deviation. So some what ifs. What if we recorded the other way, in the negative direction? So the net force would still be constant as with velocity, but it would just change the position. So the line would be going the opposite way instead. And if we dropped it instead, acceleration due to gravity would be accounted, so there wouldn't be constant velocity, and the lab would just not work overall. So our conclusion from this was that Newton's first and second law are supported due to the models having extremely similar plotting, and constant velocity and net force were supported in both, and it was a success. Thank you.